Hello, everyone. Very welcome to my presentation on exploring GSRS-mediated PBL in higher education. My name is Myung Jeong Ha, and I'm a professor at Sangmyeong University of Korea. First, I want to talk about the background of my study before moving on to the research goal and methods. Student response systems, that is, SRS, have become popular educational settings due to the widespread use of smartphones and advancements in technical infrastructure. Traditional clickers have been extensively utilized in higher education contexts. In addition, the integration of game mechanics with traditional SRS has recently given rise to game-based SRS, such as Socrative, Kahoot, and Quizlet. Socrative, particularly that supports not only multiple choice questions, but also subjective type questions, can be a more suitable option for college courses. Concurrently, problem-based learning, that is PBL, is an instructional approach that encourages active engagement with real-world problems and places significant importance on social interaction. PBL is often implemented with diverse technologies because it can fulfill the requirements of interactive communication and collaboration. Despite the benefits of PBL, challenges arise when implementing it in large classrooms. GRS technology, particularly Socrative, can mitigate these challenges by raising a comfortable learning environment with anonymous participation. The purpose of this study was to examine the effect of gender, learning styles, and academic disciplines on student perspectives on the use of a mobile-based SRS in a PBL class. Additionally, it examined the relationship between students' acceptance of SRS technology and perceived learning outcomes that are measured by cognitive scales. The research questions of this study are as follows. First, how does gender affect students' cognitive, affective, and sociocultural perceptions of using a mobile-based SRS? Second, how do learning styles affect students' cognitive, affective, and sociocultural perceptions of using a mobile-based SRS? Third, how do academic disciplines affect students' cognitive, affective, and sociocultural perceptions of using a mobile-based SRS? Finally, what is the relationship between students' acceptance level of SRS technology and students' perceived learning outcomes? The participants were 71 college students enrolled in a content course, Learning American Culture, offered by English Language and Literature Department in a university in Korea. Of the students enrolled in the course, 35, about 50% were male, and 36, that is about 51% were female. The participants' majors were put into 3 categories, including arts and design of 42 students, 59.2%, language and literature of 20 students, 28.2%, and science and engineering of 9 students, that is about 13%. Before conducting a main study, students' learning styles were examined. Because individual learning styles may moderate students' perspectives on the use of Socrative, identification of students' learning styles were required. As a result, 53 students were identified as individual learning styles, while 18 students were identified as group learning styles. In this study, Socrative was adopted as a mobile-based GSRS. To get started using Socrative, the instructor created a teacher account and assigned a room number. The room number became the login key for students to access course material through any web browser by installing the student login app. The main menu within Socrative includes a quick question section that has multiple choice, MC, true or false, TF, and short answer essay options. In addition, Space Race, with a game-based nature, enables students to compete on a team basis. This chart shows how the lectures were delivered in the class. Before dealing with the main topic for the day, a review quiz was given to the students. After the previous week's review, a background check of the main topic for the day was provided. Next, the teacher gave a lecture for the day, followed by the related movie watching. After movie watching, topic-related issues were given for group discussions. The students were expected to post discussion results on Socrative app. Then a group member made an oral presentation to share their opinions with the whole class. Web-based background survey was administered at the beginning of the semester. Its aim was to determine the students' major, gender, individual learning styles, and students' previous experience with any other course within an GRS component. At the end of the semester, the online survey was distributed to examine the students' perspectives on using Socrative and on users' acceptance of GSRS technology. It consisted of 18 questions with 5 Likert type scale and acceptance level of the use of Socrative in a PBL class. Regarding data analysis, all quantitative data were analyzed with the SPSS statistics software. Mann-Whitney U-tests were conducted to compare perceptual differences across gender and learning styles for each of the 18 measures. In addition, Pearson R coefficient was calculated to measure effect size. Then, Kruskal-Wallis test was run to compare perceptual differences across academic disciplines. Partial eta square was also used to measure effect size. Finally, Pearson correlation analysis was performed in order to identify the relationship between the user acceptance of GSRS technology and the degree of perceptual learning outcomes. This table shows student perceptions of the cognitive scales between males and females. Overall, the mean values of female students were slightly higher than those of male students regarding cognitive skills, including analytic skills, critical thinking, topic understanding, and learning benefits. However, this test showed no significant differences across genders. Furthermore, no significant differences were found between males and females regarding student perception of the affective scales. Regarding sociocultural perceptions, except for group competitiveness aligned with the feature of the game-based space race, the mean values of female students were slightly higher than those of male students in terms of interactions, sense of sharedness, and collaboration. However, no significant difference was found in student perceptions of the sociocultural scales. As a result, there were few differences between males and females concerning their perceptions of using Socrative in a PBL class. In terms of cognitive scales, overall, the mean values of students with group learning styles were higher than those of students with individual learning styles. This suggests students with group learning styles responded more positively than those with individual learning styles. Particularly, significant differences were found regarding the items of critical thinking skills and learning benefits. The Pearson R coefficient shows a large effect size calculated as 0.381 for critical thinking, whereas the Pearson R coefficient shows a small effect size calculated as 0.13 for learning benefits, which should be interpreted cautiously. Overall, the mean values of students with group learning styles were higher than those with individual learning styles regarding affective scales. A Mann-Whitney U-test showed significant differences between learning styles in learner motivation and participation, as the p-value was less than 0.05 respectively. The effect sizes for the significant differences are medium, as 0.298 and 0.324 respectively, showing the practical meanings of such differences. Regarding sociocultural scales, the Mann-Whitney U-test showed significant differences between learning styles regarding group competitiveness, interaction with peers, interaction with the teacher, and sense of sharedness. This result suggests the students in the group learning styles had more positive responses to the use of Socrative for the overall items of sociocultural scales. The effect sizes for all the significant differences are moderate, from 0.201 to 0.294. Now, let's move on to the effect of academic disciplines on student perceptions. As this table shows, the result of the Kruskal-Wallis test showed no significant differences across academic disciplines regarding student perception of cognitive scales. Moreover, the effect size were small. Also, the Kruskal-Wallis test showed no significant differences across academic disciplines regarding student perception of affective scales. Concerning sociocultural aspects, a significant difference was found across academic disciplines in group competitiveness, indicating p-value of 0.042 with a moderate effect size. The mean of the art and design was the highest mean value of 2.79, followed by science and engineering as the second highest mean at 2.33, and language and literature as the lowest at 2.00. This table shows the means and standard deviations of students' acceptance level of GSRS technology. These items were taken and adapted from the Unified Theory of Use and Acceptance of Technology. The items include ease of use, time efficacy, GSRS compatibility with the PBL class, and intention to use GSRS for next semester. Overall, the means for the items related to students' acceptance of GSRS were above the level of neutrality, which is higher than 2.5. This suggests the user's acceptance level of GSRS was relatively higher than 2.5. As this table presents, students' acceptance of GSRS was significantly positively correlated with perceived learning outcomes, but not time efficacy with critical thinking skills. The strength of the relationship for all significant finding is moderate to high, ranging from 0.30 to 0.73. Conclusion. The Mann-Whitney U-test showed no significant differences across gender. In contrast, significant differences between students' learning styles were found regarding cognitive, affective, and sociocultural aspects. In addition, group competitiveness in sociocultural factors was different across academic disciplines. Overall, students' acceptance of GSRS technology was positively correlated with perceived learning outcomes. On the basis of these outcomes, instructors should consider learner factors that would make a difference in learner perceptions on employing a mobile-assisted GSRS in a PBL class. This will eventually bring up varied learning outcomes and learner satisfaction. Thanks for listening.